Hi guys, part B now of 7E, which is integrating trig identity kind of thingies. And we're going to do a little bit of tan now, tan the man. Tan's a bit different from sine and cos. The odd and the even technique do not apply, but some other things do, which I'll show you. It's quite marvellous. Now, I've given you a couple of examples here. Now, you'll notice here, I've put in red here, find an antiderivative of something completely different for each of the following expressions. This one here and this one here. Now, an antiderivative means a specific antiderivative, not a general antiderivative. So with an antiderivative, if they ever use the word an antiderivative, then it means you don't have to put the plus c. Okay? If you do put the plus c, it's all right. It's okay, they won't mark you wrong, but you don't have to put the plus c because they're saying a specific antiderivative. So if you don't put the plus c in, you are still perfectly correct. Now, what I need to point out is when you're doing these tanny ones, there are two little golden nuggets you need to put in your integration tool chest. That is that the derivative of tan is sec squared meaning 1 over cos squared, and also that 1 plus tan squared equals sec squared. Isn't that amazing? So this all comes to our aid when we're trying to do these tanny ones, okay? Now, incidentally, if you were just doing the integral of tan x with respect to x, just tan, not raised to any power or anything like that, just bear in mind that for that particular case, you would call that sine over cos, and then you would do original function plus its derivative, original function being cos and the derivative being minus sine. That's how you get out of that one. But for these other ones, it's quite amazing. You use these two little wonderful little rules here to get you out of bother. So have a look at that. Okay, 2 plus tan squared x with respect to x. Now, if we just enlist the help of this little beastie here, 1 plus tan squared x is sec squared x. So let's put that into play here, which means we've now got the integral of 1 plus tan squared x, okay? Now, if I rewrite that as sec squared x, okay, now can you see how devilishly cunning this is? That's simply going to be x, and this one is the derivative of tan. So the antiderivative of the derivative is basically just the original function, which was tan. So that'll be x plus that. Oh, hang on, I'm going too fast. That's just x plus tan x, yeah. And as I just said above, you don't need the plus c because it's an antiderivative, all right? Just reinforcing that. So isn't that marvellous, you see? It's pretty amazing. So these two little rules here can come to your aid and make tan a pleasure to do. This one looks a bit of a beast. Let's have a look at that. Oh, not so bad. Look, not so bad. Come on, original function plus its derivative, you see? Because the derivative of tan is sec squared, see? Original function plus its derivative. So if we let u equal tan 3x, then du dx is 3 sec squared 3x, and therefore du is 3 sec squared x dx. And we're in business. We just, oh, look, there's the 3. Look, just waiting for us. Isn't that great? So combine the 3 with the sec squared 3x dx, and you've got a du there. It's just easy. I think we can easily do the old switcheroony. Okay, u switcheroony coming up, okay? Oh, how breathtakingly wonderful is that, yeah? U squared du. So you just get a 1/3 of u cubed. You don't need the plus c, and then you substitute for what u was, and I think we've just done it. How do you like that? It's pretty marvellous, I reckon. Now, that might be the end, I think, and the end is definitely your friend. Yeah, no plus c required for the same reason, yeah. And that's it. Wow, guys and gals, so that was pretty good, wasn't it? Okay, so all the best to you, and thank you for watching, and go forth and do your wonderful anti-differentiation. Make sure you do plenty of practice, okay, because you need it for this. All the best. See you soon.